In this video we'll be preparing diethylmalonate but starting all the way back from chloroacetic acid. As a note, we've created this video using clips from various different preparations that we've done, so we apologize if the continuity is not as easy to follow as usual. Let's get started. Our first minimum reactant to prepare is a strong solution of alkali cyanide. We're using the solid melt product from the reaction we covered in a previous video, which we find stores better over time. Our melt product from the reaction between sodium metal and potassium ferrocyanide weighed 95 g, which in theory contains about 1.1 moles of cyanide ion which we can use. We've got this dissolved in about 200 ml of water, with just the fine precipitate of iron powder remaining. Okay, let's filter this and remove the solid iron. Here we go. An aqueous solution containing what we'll assume is 1.1 moles of alkali cyanide. We don't need to tell you how dangerous this is. 1 milliliter of the solution contains enough to easily kill you. Now for our second main reactant. This is 100 grams of chloroacetic acid corresponding to approximately the same number of moles as the cyanide, but with the cyanide just slightly in excess. Now we're going to add 100 ml of cold water to this, and also 150 grams of ice. Okay, let's get the mixture stirring and let it chill. We need to convert the chloroacetic acid into its sodium salt, so to do this we're going to use 40 grams of solid sodium hydroxide, which is nearly a stoichiometric amount compared to the chloroacetic acid. We'll see how this goes. We add the solid sodium hydroxide slowly to the chilled mixture and allow it to react and dissolve. It's very important to do this slowly and not allow the temperature to rise, or the hydroxide will undergo a side reaction with our chloroacetic acid and produce glycolic acid instead. We don't want this. Towards the end of the addition we added some more ice in order to keep the temperature below 25 degrees C. Check the pH at the end and then add a little more sodium hydroxide if needed in order to make the solution slightly alkaline. Here we go. Our second solution, this time of sodium chloroacetate. Now we've got our two solutions for the first reaction, which will create malonic acid. Here's our setup for the reaction. We're using the cooled water bath to cool the large beaker, which is equipped with magnetic stirring, and we've got the thermometer to monitor the temperature. Okay, let's add the chloroacetate solution first. And now the cyanide. The reaction will now kick off spontaneously. We're starting at around 30 degrees C, which is warm enough for this to occur quite quickly. The temperature starts to rise. We add cold water to the cooling bath as needed to keep this under control. Getting up towards 60 degrees C now. Don't allow the temperature to go above 80, otherwise dangerous cyanide gas can be produced, as well as unwanted side reactions. We strongly recommend you use ventilation just in case. We then stirred the mixture with the temperature slowly dropping from about 80 degrees at its peak over the next 2 hours. Here we've got another 45 grams of solid sodium hydroxide. With the mixture at about 50 degrees, we're now going to add this in order to start the hydrolysis process. Add slowly and allow to cool if boiling of the mixture occurs. We had this happen on one run, as you can see. On complete addition, keep the mixture hot by heating it. Ammonia gas should be evolved quite rapidly. This is our intermediate cyanoacetate hydrolyzing to malonate. We kept this heating and bubbling for 3 hours, after which point no more ammonia was being emitted from the reaction mixture. Towards the end of this period, the mixture also turned milky and viscous due to the amount of inorganic salts present in the mixture. Okay, so now our product is present in here as sodium malonate. To get it out, we need to first make the mixture acidic. First we'll chill the mixture down again so it's at fridge temperature. Now we slowly and carefully add concentrated hydrochloric acid to the mixture. There's a little bit of ammonia remaining, as you can see by the white ammonium chloride smoke produced. We added about 150 ml of acid before the pH was down to around 1, indicating complete reaction. On chilling this resulting mixture, you can see that there's a fine white powder precipitating. The residual color of the solution is green or even blue in some runs. This is due to residual tiny particles of iron present from the original cyanide starting material being converted into iron to chloride by the hydrochloric acid, being oxidized by the air to iron 3 salts, and then reacting with a very small amount of excess cyanide to create Russian blue. Now for the slow and boring task. We need to evaporate the reaction mixture down to dryness, but without going over about 110 degrees C. Using a hot plate and a fan to blow air works well. Using a magnetic stirrer is also helpful, as without it a solid crust can form which prevents further evaporation. If you smell acetic acid, then the malonic acid is decomposing and the temperature is too high. Let's fast forward now. We've got our solid dry product which contains malonic acid and inorganic salts. At this stage you can do as we did in a previous video and add diethyl ether to this in order to extract the malonic acid. But this time we're instead going to use ethanol to extract the malonic acid from the mixture. Hot ethanol dissolves it better, and we opted to place the mixture in a microwave, which seemed to work well as an extraction method. Here's our hot ethanol containing some insoluble inorganic salts. Filter off the insoluble portion while the mixture is still warm. It's worth re-extracting the solids again with more hot ethanol in order to ensure that all the malonic acid is dissolved. Okay, now we've got a solution of malonic acid in ethanol. We're going to reflux this in order to create the diethylmalonate ester. We're using the 500 ml flask, as you can see here, and a large excess of absolute ethanol. The reaction isn't very efficient, unfortunately, and requires an acid catalyst to help things along. So we've measured out 7.5 ml of concentrated sulfuric acid. We're not completely sure why, but this seems to react to some extent with the ethanol solution, possibly because of some residual inorganic salts. Some white precipitate is formed. We've set up the flask on a hot plate, and we're using a reflux condenser and cool water. So let's get the mixture boiling and refluxing in the flask. The mixture bumps slightly but not violently. We've got a nice reflux going on now. And now we keep this mixture refluxing for the next 5 hours. At the end of this time we now need to distill off the excess ethanol. so we rearrange the apparatus and set up for simple distillation. We're using the thermometer so we can tell when the alcohol has boiled off and water remains. Be careful not to heat too strongly because the unreacted malonic acid will decompose into acetic acid if heated too strongly. The distillation takes a few hours to complete. Save the fraction of ethanol which boils off at exactly 78 degrees C and reuse it. Once the temperature gets up to nearly 100 degrees C, then the alcohol distillation has completed. So shut off the heat and allow the mixture to cool down. You can see 2 layers in the cooling mixture. Unfortunately, it seems as though malonic acid is highly soluble in diethylmalonate, so the amount of product is less than it looks at this stage. Once cool, we place the mixture into a separating funnel. The top layer is organic and contains our product, so we first drain off the bottom aqueous layer. It's quite possible that this contains a lot of malonic acid, so we're going to save this and see if we can evaporate it down and recycle this. Next we make up a strong aqueous solution of sodium bicarbonate. Adding this to the organic layer in the funnel produces a lot of carbon dioxide evolution, so there's a lot of acid still present in this mixture. On shaking, our product separates from the aqueous layer has oily droplets on the surface. The bubbles of CO2 gas generate a rather nice lava lamp type effect in the separating funnel. After a white we end up with a distinct top layer of product, so we drain off the bottom aqueous layer and then separate our product. It does have a beautiful sweet tropical fruit aroma which is fresh like ripe sweet green apples, but also with an undertone of pineapple as well. We dried the product quickly using a small amount of anhydrous calcium chloride. And here we go. Crude diethylmalonate. We'll purify this using distillation before we use it in another reaction. The yield is low though. This is just 14 grams of product obtained from using about half of our original chloroacetic acid reaction mixture batch. This is only a 17% yield from starting chloroacetic acid, but it is enough for us to experiment and do some interesting reactions with. For better yields we think that the intermediate malonic acid would need to be purified and made completely dry before esterification. But this overall process is long and arduous enough as it is, so we didn't do this. Maybe in the future. Thanks for watching and stay tuned for diethylmalonate reactions.